Mr. Investor, welcome back to the channel. Today we're going to be talking about Bionano genomics, presenting at AGBT. So first thing first, I'm going to be your tour date today. I'm going to be touring you around the exhibit hall, theatre, poster hall, network lounge and virtual lab. There's a lot of interesting companies talking about a lot of interesting stuff, but today we're going to be focusing on Bionano genomics. But there was this. Yes, there was exploration into the evolutionary genomics of spider silks. Wow, Spider-Man gets all the girls. Before we begin, for those of you in America and you want some free stocks, get your 2 free stocks valued up to $1,850. All you got to do is deposit $100 into the Webull account and the link is in my description box below. You can get Google, Facebook, Starbucks and much more. So take your chances, boys. If you're new around here, welcome to the ranch, partner. It's gonna be a mean old ride. My name is Miguel, aka Mr. Investor, and we look for some big juicy growth stocks. We've been covering BNGO since it was a $2 stock. We've also been covering NNDM and much more. If you'd like to support my channel, you can click the join just above my head. It's only 99 cents and it really helps me to create good quality content for you guys every single day. But if you're unable to join, just you hitting the like and clicking subscribe is enough for me. Thank you so much. Let's get into the video. So first things first, I want to take you on the tour of AGBT. So what is AGBT? AGBT is a world-renowned event. It's not-for-profit provider of free prestigious conference and networking events. And the one that we attended today is the general meeting. So I'm going to be showing you everything about this general meeting. You've got a nice welcome video in the middle, you've got loads of sponsors above at the top, and we're going to take a look at the exhibit hall. So here within the hall you can see these are all the different stalls. These are all the genomics companies that are getting involved with AGBT, and we don't have a stall in this one, but we do have a poster. Yes, that's us. See what's new, Bionano genomics. And if you just scroll across, you can see Illumina's here, we had PacBio, we had 10x genomics, and you can literally go into one of these stalls and see what it's about. Let's go into Illumina, for example. When you go inside the store, it usually pops up with like an intro video. You can also speak to the booth rep, as you can see here, and generally it's a place where professionals can come and have a chat, connect with them on social medias, and also talk about the technology as well as try and buy and make sales. One of the main things I found really interesting as well is the way that they've incentivized all the professionals, all of the government institutions, universities. They incentivize them to participate as much as possible. So there's a point system here where you can go in and out of different theaters, lobbies, exhibit halls. You can download stuff, and by doing this you are able to accrue points. So you can collect more points by watching booth videos, you can drop in and visit a booth in the exhibit hall, also by chatting with the live team. So basically the reason why you want to accrue these points is because you can win prizes. And by incentivizing people to go and check out loads of different companies and actually rack up points, you know, they're able to see what the sponsors have on offer, as well as be able to access all of these different prizes. So you can get a grand prize of complimentary registration to the meeting. You can even win Oculus, Beats headphones, Amazon gift cards, even a robot vacuum. So you can see it's all sponsored by different companies here on the side, so they get another sponsorship thing here. Oh, PacBio is giving away a PacBio prize. Now that that's done, I'm going to take you into the theater. So this is where we can watch all of the live presentations. Once you go into the theater, you can click view presentations and you can see everything that's on for today. Today we're going to be talking about Dr. Catherine Brownstein from Harvard Medical School. So she was using Bionano genomics optical mapping system to look for severe neuropathic disorders in children. Before I get into this, I just want to say thank you very much to everybody who donated. I'm going to be live streaming and hopefully I'll be able to get all the good Bionano genomics presentations today and tomorrow. See, there was also a poster presentation that's meant to happen tonight, but I can't seem to find access to it. I think basically it's just a poster and then there's a live chat at the side where you can talk to the person who presented it. So when we're going into the poster, we go to cancer omics here and we'll be able to go all the way down to the bottom. And Tolpova Zuzana was meant to be presenting this tonight, but I'm not sure how to gain access to this, and I'll try and put it up later on if there's anything good about it. So this is Dr. Catherine Brownstein. She's from Harvard Medical School and Boston Children's Hospital. So I'm literally going to be breaking down everything I think is vital points, but if you want to watch the full video, just look at the link above my head right now and you can watch the full video. Okay, so this is the first part of the video I found it interesting. It's basically enabling gene discovery, their research group and network, 6,700 participants, a load of departments, 50 plus states and 53 plus countries in 6 continents.
The Manton Center has been incredibly successful with 6,700 participants to date, referred from 23 departments within the hospital, 50 U.S. states, 53 countries, 6 continents, and notably less than 7% of families approached for enrollment have declined illustrating the need for this type of protocol and the enthusiasm of patients to participate in research.
The next thing she goes on to talk about is through the Manton Center, she's been able to form a lot of partnerships with industry and pharmaceutical companies.
Through the Manton Center, we've been able to form several partnerships with industry and pharmaceutical companies to work with patient cohorts.
She then spoke about automation partnerships and how they use social networking sites to help them get patient enrollment and participation.
The longest of these partnerships has been with Alexion and focused around automating the diagnostic process. We've also been able to work with social networking sites such as Inspire, where their motivated patient communities have been able to enroll in research programs.
So surrounding their cohorts, the patients that they were looking at had psychosis and they were either 14 or younger. There were patients ranging from like 4 years old all the way up to 14 years old, and they presented with a range of diagnoses from ADHD to anxiety, autism, depression, epilepsy. Lots of kids have multiple comorbidities affecting them.
Dr. Gonzalez-Hedrick was noticing an unmet need where he was seeing patients with psychosis at age 14 or younger, which was too young for admission at any of the other clinics within the state. Through working with the Manton Center, we have been able to build a cohort with over 150 patients with very early onset psychosis and discover new genes as being phenotypic expansion for this devastating condition. This research program has been integrated into Dr. Gonzalez-Hedrick's Developmental Neuropsychiatry Program, where the goal is to assess at-risk children before genotyping and phenotyping, determine mechanisms.
So now she's going to be talking about how she's been implementing Bionano genomics technology within her studies.
Since this is advances in genome biology and technology, I wanted to touch on some innovative genomic techniques that we've been employing for difficult cases. We were excited about this because it was really narrowing down this interval, showing that you could have psychosis in a very small interval and hopefully refining the candidate genes in the region.
She was saying she was having such a horrible and difficult time until they started to use Bionano genomics to optically map it out.
But we were having a horrible time getting the cells to survive, and we didn't really understand why, what was going on. Fortunately, we had just gotten a new machine called the Bionano Saphyr optical genome mapping system in our molecular genetics core facility, and we were able to get a fresh blood sample from the patient. We could use this fresh blood sample to look for structural rearrangements on the Bionano, and I will explain how we were able to do that. But long story short, the Bionano results showed that the patients had 10 genes deleted in the interval, not 3 that were seen by chromosomal microarray. Now, you might ask, how on earth did the clinical array have it so wrong? But chromosome 16 is notoriously difficult due to the high number of repeats in the region. It makes being confident in the CND endpoints and rearrangements quite difficult.
Also, one of the issues that they were saying is you have to use fresh samples. It's either fresh blood samples or you need to use, I think, frozen tissues.
The catch is that you can't use fresh or any previously extracted DNA. You have to use fresh or flash frozen blood or tissue and sample and start with intact cells. FFPE won't work. Any freeze thaw is pretty much not going to work, and you have to follow the protocol exactly.
At first I thought, oh no, this could be a big problem, but then I spoke to Nero, and Nero said, it's not a problem, mate. They just need more machines. He said, why don't they just get more machines so it's readily available and they don't need to, wait for one machine to go. They just get the fresh sample, boom, boom, boom. Are we good, baby? So here, it's not record breaking. We were working on kind of 2 cases, I think, right? But just imagine when that large Canadian network of hospitals come back to us and they're like, you know what, we're replacing all of our old methods, all of these old workflows, and they're just simply using the Saphyr, and they need more than one Saphyr in order to be, constantly running tests. This is the largest hospital diagnostic laboratory in Canada and one of the largest in the world, performing 25 million tests per year, baby. And if we're going to be frontline, serving 1,300 patients per day, and if we're going to be the big dogs in cytogenetics, we can be synergistically used next to PacBio, we can be used next to Illumina. So let's just see what happens. The next thing she was showing us was the Matrix. Neo! Is that you? Beautiful. You are the one, Neo. No bullets. The next thing she spoke about was how the analysis software is easy to use.
And the fantastic thing about Bionano is that the analysis system software is really easy to use. This is a dynamic Circos plot that shows the results at a glance. This is a chromosome 1416 translocation that we see in a patient with nonverbal autism. The inside ring are the translocations. Next would be copy number variations. Outside of that, each dot represents an indo or other type of variation.
So this was one of the biggest statements of the whole presentation. Basically, she was talking about during her PhD, it took her 3 years to map with fish and other traditional techniques. But with Bionano optical mapping, it only took 3 days.
I always show this slide with this case. Since I did my PhD on a balanced 913 translocation with hypophosphatemic rickets, and it took me 3 years to map the breakpoint using fish and backs and then southern blots to walk across the chromosomes. And the Bionano can do the 3 years of my PhD in 3 days.
Oh God, technology has come, baby. So next she was talking about being part of a consortium for C19.
We're fortunate enough to be part of the Bionano COVID-19 host genome consortium, where we are one of several institutions around the country looking at patients who have had severe reactions to COVID and trying to figure out why.
So these institutions are all sharing data together, but also remember previously, earlier on in the presentation, she's got a lot of partnerships with patient enrollment and participation programs, automation partnerships, but also partnerships with industry and pharmaceutical companies. So maybe this could be for precision medicine in the future or genetic editing. So one thing I wanted to show you here as well was we're being used alongside Illumina. So as you can see here, they've enrolled 50 patients each, and they're doing structural variation detection by optical genome mapping on the Bionano Saphyr and short reads Illumina-based whole exome sequencing and whole genome sequencing. Synergistic, baby. So these are one of the final points before a live Q&A session that they had where loads of technical questions were asked. So this was basically just stating that Saphyr finds new leads for dead-end cases.
Bionano Saphyr is providing new leads for some of these previously dead-end cases.
So one of these questions here was revolving around her, what's stopping her from exploring more and, looking into more cases. And she basically responded that the pandemic, obviously, and also the trauma caused to some patients. So they're looking to kind of explore that further towards the end of the pandemic, where they'll be running more tests.
And are you, what's stopping you from taking more of these unsolved cases and trying to use the Bionano technology for them?
So the main bottleneck right now is it's best if you get a fresh blood sample, and because we're enrolling patients from all over the world, sometimes that's a bit challenging. Also, the phenotypes that I work on with psychosis, sometimes it's really hard to justify getting a new blood draw just because it's traumatic for the patient. But we're getting more and more as patients are coming in, and the pandemic is hopefully winding down. We're going to be getting more patients and fresh blood samples to run.
And then, do you have enough results yet to start to do a comparison with, long read platforms like PacBio, or just how many unsolved cases you're able to solve with Bionano?
So we hadn't been doing that much with PacBio because we didn't have one in-house. We've had a couple cases get solved by that. Manton Center, when we've had collaborators that have used PacBio. In-house, we're working on that number. I would say just off the top of my head, perhaps 10% that we've run, or maybe 20% have had okay, yes, we think this is it. For additional avenues, like that last case I showed, we're not saying that's it. We're saying that, okay, this was a complete dead end, and now we have genes that we're going to be looking at. So for there, it's much higher for us. I would say it's up to 50%. That when we run, we see something interesting that we want to follow up on.
Yeah, and actually, that was sort of along those lines. Somebody asked the question, do you sort of see this technology as being the front line or a last resort kind of technology?
So maybe neither. I would say we would always start with exome just because it's so inexpensive now. And hopefully NGS will be able to look at copy number variations from that very soon. But I really think that whenever something is negative, going to Bionano next and not waiting and dawdling would probably be what I would want to do, or what I plan on doing.
And somebody else asked, besides being high molecular weight DNA, is there anything unique about sample prep for Bionano?
It just works best if you use their protocol. Like you can use the SHG, like Southern blot, like plug lysis, I think it's called. That will work, but there you're getting 150 kb around, and you really want 400 kb. So it just is best if you use their protocol.
And then what about the analysis? I mean, you showed us the video. That it was fascinating, but you have to somehow reduce that to be able to analyze it. What does the analysis process look like?
Sorry, I guess I didn't. I should have showed more of that. I think I accidentally skipped a slide. The analysis that's built in is really nice. It's super clean. It's a dynamic circles plot where you just click on something and it blows it up. At a glance, you can see what they have. To me, that's actually one of the best parts of using Bionano is the analysis is so slick.
And somebody asked the question, can you look at RNA with Bionano, or is it pretty strictly looking at DNA?
DNA.
Yeah, that's what I figured. So how much DNA? By the way, our meeting, there are a lot of really technical experts, so I'm not surprised we're seeing lots of questions around the technology. How much high molecular weight DNA do you need?
I actually don't know. I know that when you start, you need 650 microliters of fresh blood, or you need 5 milligrams of flash frozen tissue. So I don't know what that translates to on the amount of DNA. So sorry, because we are starting from whole cells.
So somebody asked, do the issues stemming from high repeats mean PacBio sequencing would be a better solution compared to other next generation sequencing approaches?
This is just my opinion. I hate getting an exome negative. And in the back of my mind, I'm always thinking like, okay, well, it could be repeat regions. And maybe it's just the phenotypes that I work on. But yeah, to me, PacBio and using long range in complement to these other approaches when you fail the first exome is logical. And hopefully the prices will continue to come down so it becomes more in reach. So
let me ask one last question, then we'll take it back to away from technology, more to the big picture of what you're trying to accomplish. Why is it a mixed cohort of neurological cases? What's the complexity there?
That's a stupid reason. It was because I didn't get the key. I asked for access to the cohort and they gave me the access, but they didn't send me the key of what patients were which, so I just used the whole cohort. I actually did it again last night with just the epilepsy, and it wasn't different for the average PLI for comparative for the psychosis and the epilepsy cohort.
All right, guys, that was it. I'm just going to finish off by saying thank you very much to everybody for supporting the channel. It means the world to me. Me and my brother are always like working together, editing these videos, trying to bring you the best and most valuable and entertaining content we can. So please consider subscribing. A lot of you aren't subscribed, and please hit the notification bell so you never miss these videos. Mr. Lot over and out, baby.